I want to start by just talking a little bit about how, as a nation, we underwrite preparedness and resilience. And those two terms, preparedness and resilience, these are thrown around quite a bit in this disaster preparedness domain, but they actually mean two very different things. So the term preparedness really refers to a somewhat two-dimensional concept where you identify a threat, you write a plan for that threat, maybe you buy some stuff, you train people on it, you exercise it, and then you revise the plan based on what you found, and then rinse and repeat, right? Resilience is actually something we're just starting to understand. So if preparedness is the insurance policy to reduce risk and to reduce the loss as a result of a disaster, resilience is something additive that comes into play when different facets of a community work to solve problems together. And I'm going to come back to that in just a little bit to talk about what that means in the world of disaster preparedness. But in the United States, how we fund disaster preparedness primarily comes through the federal level and then trickles down through the state down to communities. So for cross-sector preparedness, so this is across all of the various different aspects of the continuum of responders. There are two major funding streams. There's actually a handful of funding streams that come through the U.S. Department of Homeland Security, but two of the benchmark ones are the State Homeland Security Grant Program and the Urban Area Security Initiative. The State Homeland Security Grant Program is focused on states and creating statewide preparedness systems and local projects that make the state better able to respond to a wide range of disasters. And the Urban Area Security Initiative has a little bit more of a terrorism flavor to it and is focused on the high-populated, high-threat areas. And as you can see, we've actually seen a divestment in preparedness since its peak in this time frame of analysis of 2008. We've seen the state funding reduced by about half and the urban area funding reduced by about a third. That actually masks a reallocation within the urban area funding, where a couple of the high density urban areas retained the majority of the funding and a couple of others actually lost funding. The trend before 2008 is still a downward trend. There's just some restructuring to the way Homeland Security did grants that makes it not as clean of a picture. So diving into one of the core sectors, the other major stream that contributes to preparedness flows through the U.S. Department of Health and Human Services. The two major grants that come through there are the Hospital Preparedness Program and the Public Health Emergency Preparedness Program. The Hospital Preparedness Program is focused on the clinical setting, places where we receive care, disproportionately hospitals, and the Public Health Emergency Preparedness Program is more the wraparound community-based public health services. And as you can see, since its peak in 2003, we've seen a reduction by over half of the hospital preparedness funding and about a third of the public health preparedness funding. In addition to this, we've seen about $1 billion cut since over this time period for baseline public health funding for all public health services, and a national workforce reduction in the public health sector of about 50,000 full-time positions through attrition and layoffs. So I guess the big question is, so what, right? The bars on the graph get smaller, you work smarter, not harder, do more with less. What does that actually mean? So in 2012, Trust for America's Health did a survey that looked at what were the impacts of these cuts in public health preparedness. And to give just a snapshot of some of the high-level things that they found, at the beginning they found a reduced capacity and capability for mass vaccine and antibiotic distribution. The irony here is that a year earlier, the public health system actually had to use this capability. There was H1N1. Everybody remember that? There was a novel vaccine, a novel strain of influenza with pandemic potential that required an off-cycle development of a vaccine that had to be distributed through this capability. And it's been used locally for outbreaks and other situations, and yet a year later, the capacity is already eroding. That we've spent so much time and effort to build up because of the loss of resources to do this. Top-level laboratory capabilities. This is a critically important one. This is your early detection and early characterization system. And this is not something that can be bought with surge funding, right? We saw the $5.4 billion for Ebola surge funding, which is critically important. And it expands your existing capabilities, but it doesn't create new capabilities. And going down to the next one, epidemiologists. One of the key investments made by the CDC over the last few decades was to rebuild the epidemiologist capacity of state and local governments to be able to go out there to detect, investigate, and understand these diseases. and we're seeing the loss of that capability. Environmental health programs. So as we look into the extreme events that we're seeing, even just over the last 5 years, how many hazardous material spills, how much risk are we incurring through the shipment of hazardous materials on the rail lines, and through new ways of sort of extracting the last of the fossil fuels out of the earth. And yet, while the threat increases, our capacity to respond and understand the consequences continues to decrease. And finally, climate change. The state and local health departments, they want to plan for climate change. That's what was found. And they're having to delay that because they're having to focus on more immediate operational needs. Now, I checked, climate change hasn't delayed itself to wait for the funding to catch up. So these are just a few snapshots where some of the preparedness areas are eroding. But I want to come back to the concept of resilience as well, too. And so this is from Judith Rodin of the Rockefeller Foundation's book, The Resilience Dividend. And I think this makes a very important point. So when we look at preparedness as an insurance policy, as money you put in so you lose less down the road, I think one thing we're starting to understand is that if it's done properly, you actually build resilience, which is more of an investment that pays a dividend. So communities that are investing in resilience, that are creating those connections for solving these problems and bringing different sectors together to create broader ownership over what happens in the community, are experiencing something without a disaster ever happening. And it's translating into improved economic activities and generally a higher quality of life. And then when a disaster does strike, we're seeing less damage and a faster recovery process, but even more so, we're seeing a stronger recovery process because these communities are identifying that with recovery is an opportunity not just to rebuild, but to rebuild stronger. The converse of that is the resilience deficit. And so there is no middle ground, there is no baseline. If you choose not to invest or you fail to make the choice to invest in resilience, it's this downward spiral where you start to lose track, and then with each disaster, you're never quite able to recover back up to baseline. And so with each subsequent disaster, you're following farther and farther behind while the rest of the world moves on. It's my pleasure to introduce our first panel speaker, who's going to talk to us about the science of climate change and what we can expect. Dr. Adam Sobel. He's a professor at Columbia University's Lamont Doherty Earth Observatory and Fu Foundation School of Engineering and Applied Sciences. He's an atmospheric scientist who specializes in the dynamics of climate and weather. A major focus of his work is extreme events such as hurricanes, tornadoes, floods, and droughts, and the risks these pose to human society, the present and the future. He's also leading the new Columbia University initiative on extreme weather and climate.
I was asked to talk about the relation of disasters to climate change, and I want to do that because, as Jeff Sachs said earlier, all these disasters have multiple causes, so I wanted to try to put the climate change component of disaster risk in context with some of the other causes, at least to start with. So to start with what appears to be good news, I'm going to show you just a few graphs. I'm a scientist, I can't help it, sorry. This is some data on the history of really major natural disasters, and they're color-coded by type: earthquake, flood, storm, and drought, as a function of time from 1900 to 2015. And this is the number of deaths. And actually, it's surprisingly difficult problem sometimes to estimate the number of people that are killed in a natural disaster, but this is one group's best attempt at doing that. The citation is down here. It's a group in Belgium that works with the UN on this a lot. And what you see, if you look at this, you see what looks like a downward trend. I mean, the events are very rare, so it's hard to get statistical significance, but these really enormous events, these are in the millions of people. I mean, that's what these numbers are. And some of these are single events. There's a flood here in China that the estimates vary widely, but some numbers as high as 3 or 4 million people killed in a single flood. There's a drought also in China that in the 59 that's credited to be almost similarly catastrophic. So I don't think we could say that this can't happen again, millions of people killed in a single natural disaster. I wouldn't want to stand here and say it's impossible. But we haven't had one this bad in some time, and I do think some of that is real. So for example, to take some examples that I know better, if you look in 1970, there's a number here that's about 400,000. That's one storm in Bangladesh. It killed several 100,000 people. And another one in 91, that's here, that I think I actually put the little arrows, that killed somewhere between 100,000 and 200,000 people. The most recent comparable storm that hit Bangladesh in 2007 killed about 3,500 people, which would be a terrible number in the United States by our standards. The official death toll in Katrina was about 1,800. In Sandy, it was a couple hundred, depending whose estimate you take. So 3,500 is, to us in the developed world, sounds like a terrible number. But compared to what has happened in Bangladesh in the past, it's orders of magnitude lower, and that's real. The Bangladesh gets credit for that. That's working with the international community. That's better forecasting, early warning systems from the federal government down to the community level with good interaction, building shelters and getting people up above flood level, as Jeff said. So there is some success story in the history of natural disasters where in some places, including some very vulnerable places, Bangladesh is exceptionally vulnerable, we do learn things and get better, at least in dealing with these kind of short-term, immediate catastrophic events. So we haven't seen as many of these truly mega disasters in terms of death in recent years. But if you look in terms of other measures of disaster, and this is measuring the number of people affected, and I'm not going to try to say how this is defined, or economic damage from natural disasters, again, for the same set of natural disasters. And this is, I've included earthquake as well, but this is also as well as climate-related events. And you see these numbers going up very rapidly, okay? The economic damage in real inflation-adjusted dollars, skyrocketing over the last century, and numbers of people affected as well. And this is not, you can't blame most of this on climate change. Climate change is real by all means, and it is increasing the risks of some of these types of disasters, but the natural events that cause these events are not increasing at anywhere near this rate. So there has to be something else going on. And what it is basically more people moving into harm's way. So I won't, that's been studied explicitly, and we could cite studies on that, or you can just look at the history of the natural events, and you see mostly just fluctuation over this time period. You don't see huge skyrocketing numbers of floods, droughts, and earthquakes, et cetera. So the number of people affected in the economic damage are going up very fast over the course of the last 100 years. Most of that is due to population increases and development in vulnerable areas. It's more people in harm's way. A lot of the economic damage increases is in the developed world. It's wealthy people building on the coasts of Florida and other vulnerable places. A lot of the human cost is in the developing world, where it's often the poorest people living in the most vulnerable areas, including on coastlines, which are vulnerable to storms and floods. But that's most of it. There is some signal in some disasters from climate change, and I'm going to spend most of the rest of my time talking about that. But what I'll say, by way of introduction, is that so far, climate change is a relatively small contributor to these trends, sometimes hard to detect, but it's going to be a bigger and bigger contributor as time goes on. Now, when we talk about climate change and the influence on extreme events, we scientists in the field often get caught up in complicated discussions of uncertainty. There's uncertainties in climate change itself, but we know it's happening and we know roughly the magnitude of it. I mean, whether we're going to have, exactly how many degrees of warming we're going to have by 2100 is a matter for debate, not just because of how much greenhouse gases will emit, which is the subject of the upcoming meeting in Paris that Jeff mentioned and everything else. It's also partly climate science, but there are much bigger uncertainties when you ask how these rare extreme events are related to climate change, because the climate is about averages and extreme events are rare, and so it's harder to do the science. But that discussion of uncertainty often obscures the fact that we do know quite a few things with some certainty, and those push trends, even in extreme rare events, in some pretty predictable directions. So I want to now say a few words about the relationship between certain things and uncertain things. So this is an example that I've spent a lot of time on, which is hurricane. This is not my work, but I spent a lot of time studying hurricanes. And so this is a picture from the IPCC report, the most recent one, that tries to summarize what we know about how climate change should affect tropical cyclones. For one particular region I picked, the western North Pacific, which is where the Philippines, we had 2013 Haiyan, which was such an awful event. I don't know if people know, because the South Carolina floods have so dominated our news, but Guangdong province in China was hit by a category typhoon at about the same time, a couple days ago, spawned many tornadoes. Not the worst event in history, but pretty bad, actually. So western North Pacific has the most tropical cyclones in the world, so I just picked that region. And this is summarizing, the direction of change in percent compared to present climate, or the recent historical climate, that we expect by the end of the century, given some reasonable scenario for the warming of the planet. And there's a range of uncertainty, and the four measures are how many storms there are altogether, how many of the strongest ones there are, category 4 and 5 in the Saffir-Simpson scale, the average lifetime and maximum intensity of the storms, and then the rainfall. And you see, though, the rainfall is almost certainly going up. The average intensity of the storms is going up. The total number of storms is projected most likely to go down, although there's quite a big range of uncertainty. It could still go up. And the number of Category 4s and 5s is a complicated mix, because if there's fewer storms, but they're all more intense, then will we get more or fewer of the strongest ones, which do by far the disproportionate amount of the damage? That's uncertain. So we have, so these are complicated. None of this is easy to see yet in the observations, because the observations have so much natural variability, and these climate trends are very gradual. So this is a complicated and still somewhat uncertain story that you hear from those of us in my profession about hurricanes. And when we talk about it, it makes it sound as though we don't know anything and we can't predict what's going to happen. That's misleading impression. If you're worried about coastal floods, events like Haiyan and Sandy and Katrina and the Bangladesh storms, all of these are, those hundreds of thousands of people killed in Bangladesh storms. The 2008, more recently in Myanmar, which was also in the hundreds of thousands of deaths. All of these are storm surge events. They're all coastal floods where the storm pushes water onto the land. And sea level rise is a certainty. The magnitude of it, the rate is still uncertain, but the direction of it is a certainty. A meter of sea level rise by the end of the century is now, I would safe to say, becoming a middle-of-the-road estimate of what's possible, with some estimates being higher than that. The more recent IPCC report being that being on the high end, but that was quite a bit higher than the IPCC report before that. So I think we can expect by the next one, a meter is going to be in the middle of the road. And by very rough ways of measuring this, typically depends on where the storm is and a lot of other factors. But if the sea starts a meter higher, 3 feet higher, then all the floods are 3 feet higher, no matter what, even if the storm doesn't change. And to get 3 feet additional storm surge by strengthening the storm takes about a 1 category increase in the Saffir-Simpson scale. So it's Category 2 to a Category 3 or 3 to 4. So that's like saying raising sea level by sort of the middle of the road amount is like jacking up all the storms by 1 category, which is a huge number. Nobody expects the storms to change that much anytime in the near future. So that's saying that the certain thing overwhelms the uncertain thing. In other words, we know that coastal flooding risk is going up quite significantly, and we don't have to worry about all the uncertainty in hurricanes, because there's nothing they can do that's going to change that. And if it turns out we're wrong, that sea level doesn't rise a meter by the end of the century, it's a little bit less than that, it just means the same thing's going to happen, but it's going to take a little bit longer, because sea level rise is a very delayed response to climate change. And by the way, when we scientists end our plots and our projections in 2100, we're really misleading everyone, because nothing stops there. It's a very slow process after you increase the greenhouse gases to get these ultimate consequences. Storms get a lot of attention. They're very exciting. They make headlines, and there's a lot of interesting science to be done with them. So people like me spend a lot of time either in our professional lives or in the media talking about storms and floods. But I think some of the most predictable consequences of climate change are among the worst, and we spend less time talking about them sometimes because they're so obvious. But the thing we know the most about with global warming is simply the warming itself. And the planet's getting warmer, there's no question about it. It's been measured extremely well. We can see it already. The models predict it just more or less exactly as it's happening. And it's global. It's everywhere is getting warmer, pretty much. Some places a little more than others, but unlike storms and floods, which have very complicated patterns where they're more prevalent somewhere than others, the temperature is just going up everywhere. And so this is, and this has real consequences, which I think others on this panel are better qualified to talk about the consequences than I am, but I'm just going to talk about the, what the projections are. This is from the New York City Panel on Climate Change, which is a group that advises the city government on what's going to happen. It consists of a lot of people here at Columbia and NASA Goddard Institute for Space Studies across the street. And the projections are, so this is the one statistic I picked, the average number of days in New York City with a maximum temperature over 90 Fahrenheit. So the historical recent average is 18 such days. The 2020s, we expect 26 to 30, and by the 2050s, 40 or 50, and by 2100, more than that. Now, over 90, we can all survive a day over 90. This also means the days over 100 is going to go up by similar proportions. My point here is just that this is really taking us into unknown territory. Those of us who have lived in New York City, for our lifetimes, who are adults, have not experienced these conditions, and I think that makes it hard sometimes. The unfamiliarity of the circumstances that are coming makes it hard to react. And I want to show one more science plot before I conclude to sort of try to give you another way of saying that this is for a report that several of us at Lamont wrote, actually commissioned by by Jeff Sachs as part of a study on the Gulf states of the United States a few years ago. And the fact that it's the Gulf states doesn't matter. I could make this picture for anywhere on the, anywhere, and it would look basically similar. And what it shows is the probability of getting a particular deviation from the average in summer temperature. So 0 means you're at the historical average temperature for, in this case, Louisiana, Mississippi, et cetera. So this is in degrees centigrade, and this is the probability of that happening. So these blue is what's the recent history. So every summer is a little bit different than average. Some are warmer, some are cooler, and so an average summer happens, 30% of the time, 35% of the time, and a degree cooler or a degree warmer happens, 5 or 10% of the time, and anything beyond that basically doesn't happen in recent history. This, of course, is for the whole summer, so that's a stable statistic. Individual days fluctuate much more. These are predictions for the end of the century from the best climate models. This is now a few years out of date, but their most recent models would look the same, and the whole distribution is moved up. If you didn't understand my whole explanation of what these distributions mean, all you need to really see is that these two colors basically don't overlap. Okay, these distributions don't overlap, and what that means is that although every year is a little bit different, by the end of the century, and perhaps sooner than that, the coolest summer within the range of variability occurring at that time will be warmer than the warmest summer that anybody alive has experienced, or their grandchildren or their grandchildren. So it's just to say that the climate that's coming is really outside the envelope of what we've experienced, and I think that's a psychological barrier to dealing with these problems, that we react. There's this, Erwin talked about the snooze alarms. We try to react for a little while after there's a disaster, and then people get it when it happens. And so we're seeing, for example, in New York City after Sandy, we're seeing a lot of things happen. There are going to be fewer generators in basements now because there's this brief window where we take it seriously. But the things that haven't happened yet are the things that's really hard to bring attention to, and I think with climate change, it's a really massive problem that people just can't grasp it at the gut level that we grasp it after the disaster happens. But it's really a lot better to react to climate change before than after, because you cannot emit the carbon, but getting it out of the atmosphere is something at this point that we don't have the capability to do. We may never have the capability to do it, and reversing the climate change, is something that we otherwise can't do. So I just want to make a few points by way of conclusion. Although there's a lot of uncertainty about extreme events in climate change, we do know some things quite well. Temperatures going up and sea levels going up. The only uncertainties are about the rates, but the rates are certainly big enough to be serious problems. We've already seen significant rises in temperature and sea level. Those are already having an impact, but they're going to be bigger in the future. These affect other kinds of disasters. So temperature is one of the direct factors that makes droughts and wildfires more likely to occur. So things like the California drought that's been going on for the last several years, the best estimates from the science, most of it done here at Columbia, suggest that the rainfall deficit in the California drought is probably a result of natural variability so far, but the temperature makes it worse by cooking all the water that's already in the soil out of it. And so you get a really bad drought when you have heat and lack of rainfall at the same time. So if it's warmer all the time, then the probability of just having such an event goes up. The same is true with fires. This catastrophic wildfire season that we've seen in the West this last year is some of that's natural variability, some of it's the ongoing drought, some of it's the El Nino, but it's the kind of thing we're going to see more without question as the climate warms. And the same with sea level rise. As sea level rises, it makes coastal flooding more likely. So there's uncertainties, but there are certainties that are driving risks in a worse direction. I'm not, going to talk about this much. Others have mentioned it, and I'm sure others will after me. But the climate stress and disasters can be causes for follow-on effects like wars and forced migration, and those are not always directly counted when we look at the numbers of what the human impacts of disasters are. A lot of the counting of how many people are killed in a natural disaster is very conservative and looks at immediately attributable deaths. But if we really take the big picture, we know now that things like Syria, the Syrian conflict, which is partly drought-induced, it seems, and that drought, it seems to be partly climate change-induced. We're going to see more of that. So, I mean, we really need, this is so obvious as to be maybe a cliche to this audience, but we have to say it anyway, we need both mitigation and adaptation for climate. Mitigation in this context means reducing greenhouse gas emissions. That's a very long-term thing, right? If we reduce our carbon emissions now, it has an impact that's very hard to detect in anyone's, immediate perception or time frame, but a climate agreement, if we could get a strong climate agreement in Paris this December, that saves lives. It's hard for us to see that, but it really would. And so I think we can't lose focus on that. At the same time, some climate change is happening. It's already happened, and more will happen without question. So what we call adaptation, which means dealing with it, is something we really just have to take seriously through all the mechanisms that have been mentioned so far and all that will be talked about in the rest of the time. So that's all I have, and thank you very much for your attention.
Thank you, Adam, for really connecting us with the science, but also with the long term, what that human impact looks like, which is such a critical piece of the puzzle in thinking about how these extreme events will impact us and our communities. So as we get set up here, I'm going to introduce our next presenter, Dr. Elisaveta Petkova. Petkova is a research associate at the National Center for Disaster Preparedness here at the Earth Institute at Columbia University. Her research explores questions at the intersection of natural disasters, climate change impacts on human health, and building resilience to climate-sensitive hazards such as hurricanes, heat, and drought.
So my talk will be about the three increasingly important environmental threats that Adam just mentioned: drought, heat waves, and wildfires. And in order to illustrate what kind of impacts such environmental disasters have had throughout history, I'm going to start with a story about one of the most fascinating mysteries of archaeology: the collapse of the Mayan civilization. The Mayan civilization flourished thousands of years ago in present-day Central America, and they have developed fascinating architecture as well as sophisticated knowledge and art. However, they collapsed suddenly, and scientists have been puzzled about what caused this sudden collapse. One hypothesis was that severe drought has led to the downfall of the Mayan world. And recent evidence has suggested that this as well may have been the case. This is a study by Kenneth and colleagues that has analyzed stalagmite samples and has derived a 2,000-year drought record, indicating that there has actually been a severe drought lasting for decades that happened exactly at the time when the Mayan society experienced the downfall and its eventual collapse. And even more importantly, a recent study by Columbia colleagues has indicated that aggressive deforestation has amplified the impacts of this drought. And as Professor Sachs has mentioned before, drought is never the singular reason such events happen. And it is an important environmental driver that functions together with social and political ones. This is not a novel concept. In this book by Yale geographer Ellsworth Huntington from exactly a century ago, he explored the link between civilization and climate and noticed that many of the great nations of antiquity appear to have risen and fallen in harmony with favorable or unfavorable conditions of climate. How does this relate to the world today? As a society that is increasingly embracing concepts such as sustainable development and resiliency, aren't we able to respond to drought in a way that doesn't let it become a serious threat? Well, present evidence from Syria doesn't seem to provide evidence for that. As a result of the drought that occurred from 2006 to 2010, 1.5 million people have migrated from rural to urban areas. They have left behind livestock and have looked for work and new livelihoods for themselves and their families in the urban areas. Crop failures resulted in prices going up, and the water and food shortages, coupled with stress already experienced by the cities, eventually contributed to conflict. And something that is even more important is evidence emerging from a recent study. This one is by colleagues at Columbia as well as at the University of California that has linked the Syrian drought to climate change. And I think it is important for us as a society to start understanding that severe droughts exacerbated by climate change may not be something that we can avoid at this point. They play a major role in national security as well as international stability. And they pose really big threats as societies are really struggling with mass migration and with fighting for limited resources. This may especially be the case for regions like the Middle East that is already facing a serious water crisis. And what about countries like the United States that have much more advanced water policies and have a much more advanced capacity to deal with environmental disasters such as drought? At the moment, California is experiencing the most severe drought in its history. This chart illustrates data from the Drought Monitor. And what we can see is that today, most of the state is experiencing extreme or exceptional drought conditions. And even though the state has a substantial adaptive capacity, economic losses in 2015 alone have been estimated to reach about 2.7 billion. 21,000 jobs were lost as well. And there are many more social and public health impacts that we can't even quantify at this point, that include social dislocation, malnutrition, as well as physical and mental health. And I just want to point out that mental health impacts are especially important when we're thinking of chronic climate-sensitive disasters such as drought. And there have been many documented cases of mental health impacts such as depression and even suicide among vulnerable communities. And what is the face of vulnerability? On the picture here, we see Juana of East Porterville, California. She's a single mother living in poverty and struggling to make ends meet since her well went dry in 2011. People like her in the United States and around the world are most vulnerable to the impacts of drought and will continue to be more vulnerable in the future. Rural and agricultural communities are especially at risk because they depend on their land and the climate for their survival. People of lower socioeconomic status are always more vulnerable, as well as those living in isolation or having a certain underlying health condition. For example, people needing dialysis may be especially vulnerable. Heat waves are another growing challenge under a changing climate. And we define heat waves as periods of unusually hot weather over an extended period of time relative to local conditions. Of course, a heat wave in Australia is not going to be defined the same way as a heat wave in Germany because local populations are adapted to their climates. However, heat waves are a global threat. On this chart, I have presented data from the M-based disaster database, and we can see that heat waves occur around the world. Some of the most severe heat waves that have occurred in recent history include the one in Russia in 2010 that took over 50,000 lives as a result of smog and heat exposure. And of course, the heat wave in Europe that resulted in over 70,000 deaths, 20,000 of them in France alone. And in the United States, the most deadly heat wave in recent history has occurred in Chicago in 1995 when over 700 people died. The next chart just illustrates mortality during the 2003 heat wave in Paris. And on the left y-axis, we see the number of deaths per day. On the right y-axis, we see the temperature in Celsius. What we can see is that the death toll is rising with the prolonged exposure to heat. And this is something to remember when we think about heat waves becoming not only more frequent, but longer with climate change. We can see that on the 12th of August alone, there were over 300 deaths in Paris. And this represents an increase of over 250 deaths over the daily baseline. Now, individuals who are young and healthy are generally not afraid of the heat, and they don't suffer from deadly consequences during heat waves. But there are certain populations, such as children and especially the elderly, who are very vulnerable. People living in social isolation as well, they have nobody to call when a heat wave strikes, and they have no way to seek help even if they don't feel well. As well as people with certain health conditions such as obesity and diabetes, and people of lower socioeconomic status as well, are always more vulnerable during heat wave periods. There have been several great books that have explored the vulnerability of populations and have told the stories about some of the victims of heat waves. On the left, you see a book by Eric Klinenberg called Heat Wave that has explored the heat wave in Chicago in 1995. And on the right, there is another great book by Richard Keller about the heat wave in France in 2003. And something that I want to just mention because it is important is that in contrast to drought, that is a bigger concern for rural populations, heat is something that is a bigger concern for urban populations. And this is the case. One reason why this is the case is because of the urban heat island effect. The term heat island refers to the build up urban areas that are hotter than nearby rural areas. And this temperature difference can reach up to 3 degrees Celsius during the day and up to 12 degrees Celsius during the evening for a city of 1 million. So when we're thinking about the future, we know that there is a demographic transition taking place, and we're moving towards a world where there will be more elderly and more urban residents. Therefore, heat waves are not only a threat because they may become more and more intense and more and longer in duration. We will also have a larger vulnerable population that we would need to protect. And finally, wildfires frequently occur together with heat waves and drought. In 2010, I'm sorry for the typo, in Russia, there were devastating fires that have caused 50 deaths and have resulted in 15 billion in damages between July and September. And this season in California, according to some estimates, there has been more land burned compared to the whole previous decade. And for this wildfire season alone, there has been an estimated over 200 billion in damages so far. So this is something to really think about in the context of what we may have to see more and more in the future. And since I wanted to provide a good overview of the landscape of those three threats, I didn't have much chance to talk about adaptation. But one point that I'd like to make is that successful adaptation should incorporate preparedness, response, and recovery strategy in the context of long-term climate adaptation planning. And I just want to give one example about New York City, because New York City has made a lot of progress, as many other cities in the United States, in terms of responding and planning for heat waves. So after the United States has experienced several devastating heat waves, including the one in Chicago and another one in Philadelphia, cities like New York have implemented a lot of measures such as warnings, cooling centers, and various educational programs that protect vulnerable communities. And not only that, but a lot of work is being done now in the context of the New York City Panel on Climate Change that was first convened by Mayor Bloomberg. In this work, future projection of climate change are combined with various other estimates on human impacts in order to advise the local government how to best prepare for future impacts. And it is a phenomenal collaboration between experts from climate science, population impacts, disaster preparedness, and risk management. So with this, I just want to conclude with a couple of summary points. First, severe drought exacerbated by climate change may at this point be inevitable and should be recognized as a growing threat to national security and international stability. Second, drought, heat waves, and wildfires have wide-ranging and devastating social impacts, including morbidity and mortality, dislocation, and economic losses. And finally, the already vulnerable population, including children and the elderly, people of lower socioeconomic status, and the chronically ill, are the most likely to be affected by drought and heat waves and will likely suffer disproportionately under a changing climate. Thank you very much.
Thank you, Elisa, for that great presentation and for really connecting the human factor with all of this. For our final presentation, we're going to take a little bit of a right turn here. And while we've been talking today a lot about natural ecosystems and the impact of human activity on them and the need for human adaptation to help mitigate changes in these natural ecosystems, our final speaker today is going to talk to us about man-made ecosystems, particularly those created by information technology and the kinds of threats and vulnerabilities that we face in terms of cybersecurity. If your biggest concern is losing your identity and losing your data, I assure you there are much more profound things to be afraid of. So with that, let me introduce Dr. Jeb Weissman. He's the Director of Strategic Technologies for the National Center for Disaster Preparedness.
Usually when I walk into a room, people say, here comes the angel of death. But for once, there are people even more doom and gloom than I am. So that's great. Thanks. Often when I speak to students, I start with the typical raise your hand. I won't ask you to raise your hands, but how many of you have a smartphone, an iPad, a laptop, all that sort of stuff? And everybody raises their hands. It's 100%, even when I'm talking to kids in socioeconomically depressed communities, schools. So this is rapidly becoming, here in the United States and across much of Europe and Asia, the standard, a standard accessory. Like a wallet or a newspaper used to be. And then ask the natural next, somewhat ironic question, how many of you could write code to make any of those devices work? And the answer is usually, except when I'm talking to kids at like engineering schools, no one, all right? And so that's a really important place to begin. It's because we don't actually understand, in large part, how the tools we are dependent upon work, okay? So this question of cyber threats and cybersecurity is extremely important because A, we don't get it, B, it's connecting us all together, and C, we are leaning on it as a response to the very things we've heard about in the room today. In fact, I think Jeff alluded to it. One of the very first things that everybody was proud of, and I was called to help with this a little bit, was bringing cell phones and internet connectivity to the refugee camps in Europe. And we'll talk about that a little bit in a minute. Technology is a connective tissue. It's also a source of physical and social disaster, and I think you can anticipate where I'm going with this, but we'll get there when we get there. Finally, we also tend to assume that technology, information technology in particular, is stable. And we are increasingly using it as a repository of knowledge. I will Google that. I don't have to remember that. I grew up on a farm. So you had to learn things, and often you learned them the really hard and painful way, but you tended to retain them. The other day, I decided to make an apple pie. It's an exciting moment in my 55 years. And I looked it up on Find Cooking, and then I had to look up a crust, and my internet connection froze, and I had to go find a cookbook, which was exciting because we had one right there in print, and now I think you know where I'm going with that. All right? We don't remember stuff. We don't know stuff. We look it up. And during a disaster, looking it up may not be the best strategy available. All we have to do is think about The Martian, which a lot of people have seen, and it was kind of an interesting book, but it teaches an important point. We can look stuff up, but if you don't know the core, the base, or the operational or functional nature of what you're looking up, you can't extrapolate, you can't learn, you can't adapt. Adaptation, as every single one of the presenters before me has said, is vital in our response to disaster. So my favorite cyber threat, 1903, it's the first modern cyber threat. They were demonstrating Marconi's exciting new wireless telegraph system, what some people refer to as the Victorian internet, and somebody hacked it. It was in 1903 and sent insulting and profane messages that the audience could see on the projected screen. The reason I call this Boundary 1 is this is a talk about extreme events. We're hearing about extremes of heat, extremes of weather, extremes in socio-political change, transformation. We have no idea what an extreme is in the cyber world. It's relatively new at a global level. It's certainly, everybody discovered the internet in 1994 when it was opened up and commercialized. We have no idea what the boundaries are. So let's start to take a look at the underlying aspects of this. Cyber threat motivations. I'm not going to read this to you. You can see it. There's no magic here. It's all the same things as the anthropologist part of my world. It's all the very same things that motivate us to do other things, motivate us to undertake threatening behaviors in the cyber universe. I talked about the cell phones and internet connectivity in the refugee camps. Phenomenal. We can connect to family. We can bring families together. We don't feel alone. We don't feel isolated. We'll return to technologies and technical communication systems that are important and modern to us, and that is great. But they are also means of social control. We can monitor them. We can use them to undermine dissent. We can use them to control communication. These are major sources of down-the-road radicalization. These are sources of power. And interestingly, they are sources of power that transcend socioeconomic status. We can manage all of this blindly and without regard for how much money you make or, in large part, increasingly where you live. But in refugee camps, these are a group of people who are particularly vulnerable. Because as Dr. Redlener mentioned earlier, children are expected to be displaced for 17 years of their lives. I saw that statistic too. That's a long time to have people managing your information and you not necessarily being aware of it. Remember, we don't know how to write code. We don't often know what's going on, so we don't know what and how our information is being used. So moving on to informing our extremes, because part of our question here is what is informing our extreme. Let's take a moment and talk about what's an extreme. Well, extreme is the far boundaries of the envelope, right? In 1903, it was hacking the telegraph demonstration with profane words, which was a pretty radical thing in the technology sense. But we have crime, right? We find new and exciting ways to undertake criminal behavior. Now, we have ideology. And you'll forgive me, but you have to mention Ashley Madison and 32 to 35 million people, depending on how you count it. Was that a crime? Was it an ideological statement, right? Because people were pissed off that information that was supposedly being erased wasn't being erased. What was it? Was it an engineering activity? These things all meld together, they blur together. But when we get down the list, we get to the cosmos and not Phil. There's a famous set of famous recording started out, I think, on the Jack Parr show with Mel Brooks and Carl Reiner, called The 2,000-Year-Old Man. This was followed up in 13 years later with, cleverly enough, The 2013-Year-Old Man. And there's this story about how God was found. And they're out. Phil was the leader. And Phil had a bigger club, big guy, Phil. Phil was the boss. If you pissed Phil off, he hit you. And then one day, a bolt of lightning hit Phil. And everybody turned around and said, there's something bigger than Phil. When it comes to managing information technology and things that are informing our extremes, the cosmos is way bigger than Phil. It's way bigger than us. Whether it is solar storms, it's asteroids, because the fodder of movies, floods that invade data centers, things we found in New York. The point here is that nature, physics, culture, these things all are material and social context for our information technologies and for the things that begin to define extreme events and extreme behaviors in our cyber world. I was just thinking, so we had the floods in Thailand a few years ago, technomaterially. Hard drives manufactured in that year actually undergo rapid catastrophic failure. Nobody realized this, but hard drives are manufactured where? Thailand. And even though they rebuilt the factories and even relocated them because of material changes and because of changes in the people working in the factories, we experienced this cyber-related activity. Servers have been failing all over the world because of the floods in Thailand. Nobody understood why until a couple of years ago. So let me tell you another story. Not the Forbin Project. Anybody knows what that's a reference to Colossus, the Forbin Project, which is basically a dystopian story about an attempt to make a big computer that was going to keep us all from having nuclear wars. And the computer really was programmed to protect us. And as such, it basically took over. It was kind of 1984 sort of thing. Here's a different story. So imagine a setting where everybody's electronic health record is put online. And imagine that we can have genetic tests, and all those genetic tests are loaded into those databases. And then we can actually have pharmacy data stored too. So we can, order our medications online and connect them to our electronic health records. Everybody needs to see our lab information as well. And let's add some advances in personalized medicine, right? Now, I know this is a fantasy world that, started happening, 10 years ago? Let's add some advances in immunotherapy and some robotics, like robots that actually distribute pills, so that then the pharmacist just checks them to make sure that it's the right number and then gives them to you over the counter or in the hospital. Let's program a computer to collect this information. Let's make it somebody nefarious, like me. And I program a computer to do this, and then I go away for 18 years. I'm collecting the information about every baby born in 2015. And 18 years from now, I have this really sophisticated model of every human being in the United States, or Germany, or in a Syrian refugee camp. But in the United States, all these 18, 19, 20-year-olds, particularly kids who are living in socioeconomically depressed communities, become soldiers. They join the Army, the Navy, and the Marines. I can create a targeted cyber attack that I can launch anonymously. I don't even have to be around. I started it 18 years ago. And now I can change your medications, right? Because a robot's handling that. Or I can introduce personalized viruses. Now, I am not saying this is going to happen. What I am saying is, you tell me in 1994 that what Ashley Madison could happen today. And then let's extend this out to espionage, to global warfare, to control of populations, to to sleeper agents. Right? People who are activated later on. Well, now we just have to do it with computers, and we don't actually need people, and we walk away. Again, we're back in Angel of Death land, I know. But the point is, we don't really know what an extreme for a cyber event is, but what we do know is everything I just described can begin right now. Initiators and sponsors. Part of the challenge here is that our sophistication is growing radically. I mean radically. What we can do now is stunningly different than what we could do 5 or 10 years ago at a mass scale, right? And at the same time, we have a falling sophistication, easier entry, and shall we say, a simplified global view amongst the general populace. So people who have no idea what they're doing can pay money or push buttons, we call them script kiddies, to launch an attack, not really understanding necessarily what they're doing or not really understanding what it takes to do it. They can just do it. And once again, then we factor in climate change, which is in fact changing the demographics of technological distribution and the need and dependence on technology, and of course, Phil. So the elements of an extreme and not so extreme cyber threat, it's actually pretty simple. Hardware, computers, telecom devices, all that sort of stuff that you're all looking at while I'm talking. Software, that's the ones and zeros that people like me know how to push around. Wetware, that's your brains. And both in terms of generating this stuff and also being the victim of this stuff. And then hubris. Okay, folks, hubris, this is in many ways the punchline. I mean that in the modern sense. Hubris it seems to be a human condition, right? It's defined by humanity. But it's this belief that it's not going to happen to us, or we can control it, or we're right, or we're right. It's going to be okay. We have all these motives and drivers, but these are the four elements that make up a cyber threat, and particularly will inform an extreme one. So some bits and bytes here. We don't know what extreme cyber threat is. We can imagine the worst. Launching a global thermonuclear war in war games is, sort of amazing that it didn't happen. And Eric Schlosser's Command and Control is a pretty compelling and spooky discussion about that. Or is an extreme event leaking the Sony Pictures movie scripts, or is it an asteroid hitting the Earth? What is realistic and what is conceivable? It's a rapidly advancing target. We grow more sophisticated so we can advance it and create our sleeper terrorists in 18 years. We tend to think in the here and now. Folks, this is a real problem. When we start to talk about any extreme event, it is particularly problematic in the cyber world. We focus on the economic and reputation damage, whether it's Sony or Experian, who should have known better, and all those T-Mobile customers who got to share their data with all sorts of people around the world. Warfare and espionage come to the fore only when someone gets caught. And I don't know, at the end of the day, we need to begin to think a little bit more creative and a little more long-term instead of this thrust and parry, you did it, I did it. So I'm going to jump down. Once again, we remember the majesty of his nature, something bigger than Phil, and assuming an extreme cyber threat is survivable, and I think we can assume that, assuming it's not global thermonuclear war or the release of mass toxins in some way that we haven't imagined yet. We need to be creative to anticipate scale, scope, and novelty, adapt to variations, be resilient to recover and move on, and be responsible and fix secure critical infrastructure without politics or excuses. Where have we heard that before? The solutions, like the problems, are exclusively human. These are man-made issues. Even in a case where a solar storm knocks out a power grid, it is because we failed to protect the grid, which we are more than capable of doing. Better design philosophy and attention to all its attendant ramifications. Better education for engineers, the general population, and policymakers. And I don't just mean the academic stuff in the science sense or the change your password sense, but ethics education as well. We are not clear anymore about what's right and wrong. That varies across the globe, but nonetheless, this is missing. And of course, Semper Gumby, which is a military term that really means always flexible. To draw on the Marine Corps, adapt, overcome, improvise. This is fundamental in such a rapidly shifting environment, such a man-made, human-controlled environment. We have to be extremely flexible. Apply science and engineering to accommodate nature. We can't change nature. The Army Corps of Engineers has been unsuccessful doing that with the Mississippi River for 200 plus years. So at the end of the day, we must apply our science and engineering in information and other technologies to accommodate nature. Finally, technology, no matter how we think we've built it, is adaptable by others just as in any other engineering technology system.